Hey guys, hello everyone and welcome to the channel. So this particular video is going to be about mathematical tools. Now this is a very important video, especially for those who are from non-mathematics background, because in order to understand physical chemistry it's very important to know mathematics behind that. Okay, especially there are three things from mathematics which are very important and they have been used in your chemistry in lot many chapters, right? So I am not going to talk about complete maths because it's very vast. I'll be just talking about the three very important parts of it. That is, I'll be talking about functions, I'll be talking about derivatives and integrals. So this particular video is going to be about functions. In the next part, I'll cover derivative and integrals because I want to make this very sure that you all understand these things. Okay. So today in this particular video, we'll talk about functions, in which we'll talk about graphs and equations. We'll talk about that what are different types of functions, what are the graphs related to them, and how these graphs changes when you combine the functions. Okay, this is very important, and I also give you references that where these graphs will be used. Okay, so let's go straight to the topic. Alright, so the first and the very important function is your straight line. Okay, it's a very important function, and remember, function. I guess all of you know what function is. Function is like a mathematical, it's like a mathematical generator where you give some input and you get some output values. Okay. Now over here on the screen you can see this is the equation for the straight line given by y is equals to mx plus c, and this equation is called a slope-intercept form of equation, and this is the most widely used equation of a straight line. You will find this equation a lot many places in the chemistry chapters when you will do physical chemistry. Okay, I'll talk about them later, but let's look upon these graphs first of all. So when you have y is equals to mx plus c, where m denotes the slope of the curve or the slope of the line, and c denotes the intercept on the y-axis. Now if this is a particular line, this red color line is the equation of y is equals to mx plus c. So it will have a slope. Slope means that about what angle it is slantly present to the x-axis. Okay, with respect to the x-axis, how many degrees it is actually slant to. Okay, or you can say that slope is actually given by tan theta of that particular angle. Tan is a trigonometric function. Okay, so tan theta is there. Now this is called as your intercept. Intercept is given by c, and that's what is denoted over here. Now depending upon the values of m and c, you can have different types of lines. For example, if you have c is equals to 0, the equation and the slope is equals to 1. So if you have slope is equals to 1, that means if your tan theta is equals to 1, or you can say that theta is equals to 45 degrees. Okay, the angle is 45 degrees. In that particular case, the slope will become 1 and the intercept is equals to 0. In that case, the line which will be present over there will pass through the origin, that is from the center, and this is how the line will look like. Whereas if you have slope is equals to 0, that means if your tan theta is equals to 0, or you can say that theta is equals to 0 degrees, in that particular case your intercept, and let's say the intercept is c, the intercept on the y-axis is c, in that case you will get a straight line which is parallel to the x-axis. You can have one more type of equation where you will be having equation like x is equals to c. In that case, the line will be represented by this. Okay, the line will be actually parallel to your y-axis. Okay, and this particular distance will be equal to c. So it goes like that. If it is y is equals to c, the line will be parallel to x-axis. If it is x is equals to c, the line will be parallel to y-axis. So this is what you have to understand, and you should know. I guess this is much clear to you. Now the question is that where these lines will be used. Okay, so in chemistry you will see these kind of curve everywhere, almost everywhere these curves are present. Especially you will find these in kinetics when you form the different equations of kinetics based upon the rate versus the time, or the concentration versus time. So various curves are there in which you will get these kind of lines. Okay, also if you remember Lineweaver-Burke plot in your enzyme catalysis, so over there also Lineweaver-Burke plot, there also you will get a straight line like this, okay, having intercepts over here. Now there is one more kind of equation for the straight line which is called as the intercept form, and it's written like x upon a plus y upon b is equals to 1. The line is obviously a straight line, but here this a and b denotes the intercepts. Okay, as a denotes the intercept on the x-axis, whereas b denotes the intercept on the y-axis. So if you have any equation and if it is asked what is the intercept on the x-axis or what is the intercept on the y-axis or something related to that, you can reduce the equation in this form and then you will get a and b, which is going to give you the intercepts. Now this can be used in different ways. It can be used in your adsorption isotherm equations. This can also be used in your equations related to Maclaurin constant. So yeah, this can be utilized a lot many places. Okay. Alright, so this was about the straight line. Let's talk about the next function, which is called as the modulus function, and this is also one of the important function. It's denoted by y is equals to mod x, and mod x has a certain value that it will be a positive number. It will give you a positive number if your x value is greater than 0. That means if you are putting any x value which is greater than 0, it will remain as it is. And if you put any x value which is less than 0, in that particular case, what you will get that particular value to be minus. Okay. For example, if you are putting x is equals to minus 3, in that case y will become minus of minus 3 and overall value will become positive. Okay. So that's how the modulus function works. That means whatever value of x you are putting over here, you will always get a positive value out of it. So this is how the curve or the equation of this y is equals to mod x looks like. Now this is a typical equation or a typical graph for the modulus function. Let's say if I just change the function a little bit and if I add a constant a to that, so in that particular case my curve will shift towards the left hand side with a units, whereas if I write down y is equals to mod x minus a, it will shift towards the right hand side with a units. Okay, this is happening. How you have to identify this, that where this intercept or where this particular point will be present on the x-axis. So for that you have to just take it equal to 0. So put x plus a is equals to 0. You will get x is equals to minus a. So that's why it will shift in the minus a direction, okay, in the negative direction. Whereas here if you take x minus a is equals to 0 and if you get x is equals to a, that means you have to shift that point in the positive x direction. You can change these functions according to the given conditions and the graph will also change as it is. Okay. So this was about the modulus function. Let's talk about parabolic function, okay, or also called as quadratic function. Okay. These are also called as quadratic functions. Now in quadratic function, it's given by y is equals to x square. The typical curve looks like this, that y is equals to x square. You are putting the value of x, and for each value of for every value of x, for every value of y, you will get two values of x, because x will be equal to under root y and that will be in plus minus. So for any value of y, if you put, you will get two values of x. So if I put y is equals to, let's say, 1 unit, so here I will be getting two values of x. One will be positive value and one will be negative value. That's what this function tells you about. Now this function will shift according to the changes which you will made over here. These are called as the x-intercepts. This can be calculated by just taking this equal to 0. If let's say I have x minus 2 whole square is equals to y, in that case I will find out that x is equals to 2, right? So in that case the point will shift towards 2 over here. Okay, so this is how it will be. Next is exponential function. This is again one of the very important functions, because there are a lot of equations in your chemistry where we utilize this particular function. Like for example, in the Arrhenius equation, where we have that k is equals to a e to the power minus ea upon rt. Although it's a negative term, but yet you should know about both of them. Okay, so let's say we have y is equals to e to the power x. So that's how the curve looks like. You can see that the intercept on the y-axis is at point 1. That is because if you put x is equals to 0, okay, if you put x is equals to 0 over here, if you put it 0 e to the power 0, then in that case y will become 1. So whatever value of x you will put, the y value will corresponding to that will follow up this particular function. Okay, so the intercept on the y-axis will be at x is equals to 0 and y is equals to 1. That is going to be the coordinate. So if you change this particular term and if you make it anything like y is equals to 2 to the power x, in that case also this is going to pass through the same digit, okay, through the value 1. So that is going to intercept over here. That I will talk about in the further functions. So for now, just remember that y is equals to e to the power x is called as exponential growth curve. Okay, this is called as exponential growth curve because it's increasing, the function is increasing exponentially, and it will intersect the y-axis at point 1. Okay, that's what you should know. Next, let's talk about the two of them, that is y is equals to e to the power x and y is equals to e to the power minus x. So this we have already done. This is called as exponential growth, whereas this particular one is called as exponential decay. Okay, exponential decay. So in the decay you will see that it is going to decay or it is going to decrease, the curve is going to decrease, and remember that it is also going to intersect the y-axis at point 1. So the coordinates are 0 and 1 for this particular point. One more thing which you have to understand, that this curve is not going to touch to the x-axis. Okay, this is not going to touch to the x-axis anywhere because if you put e is equals to, like if you put x is equals to infinite, in that case you will get y is equals to e to the power minus infinite, and e to the power minus infinite is actually equal to 0. So you'll get y is equals to 0. So that means it is going to intersect the x-axis when the x value will be infinite. So if you keep on making it infinite, if you keep on extending it, it is going to touch the x-axis at some infinite value of x. Okay, the exponential curves can also be like given in different terms. Just like you have y is equals to e to the power x, you can also have y is equals to 2 to the power x, or y is equals to 3 to the power x. All these curves are shown over here all together. You can see this particular red line is y is equals to e to the power x, this green one is y is equals to 2 to the power x, and this blue one is y is equals to 3 to the power x. Now you should know one thing, that the value of e, the numerical value of e is 2.70 something, okay, 2.708 something. So that means what? That if you keep on increasing the value of this term whose power x is, the curve will shift more near to the y-axis. That means what? If I have to plot y is equals to 7 to the power x, in that case the curve will be drawn like this. Okay, it will go much near to the y-axis. It will go like that. So this orange line is showing you y is equals to 7 to the power x. So if you keep on increasing this digit over here, the curve will move more and more towards the y-axis. That's what you need to know. But the thing which is going to be common is the intercept on the y-axis, which is going to stay 0 and 1. That's because of putting the value of 0. If you put x is equals to 0, you will always get y is equals to 1. Whatever the number you are writing over here, that does not matter, because anything to the power 0 will eventually give you 1. Alright, the next type of function is your power functions, okay, which are called as power functions, given by y is equals to x to the power n. Now x can have two values. It can either have even values or it can either have odd values. These are the different types of curves. Over here you can see the even curves, like for green color we are representing x square, y is equals to x square. Orange one is y is equals to x to the power 4. Blue one is y is equals to x to the power 6. So as you increase the power, the curve will become more flat at the bottom and it will become more near to the y-axis. For example, if I put y is equals to x to the power 10, so it will be much near to the axis and it is going to be more flat like this. Okay, so the curve will become more flat at the bottom. You can see the green one is not that flat. The curve is like this for the green one, right? It's going like this. For the orange one, it goes a little bit like this. For the blue one, it goes more flat. Okay, so as your values are increasing, the curve is becoming more flat at the bottom, and the curve is coming more closer to the y-axis. Next, let's talk about the odd power functions. For example, if you have x to the power 3, x to the power 5, x to the power 7, except x to the power 1, which is like y is equals to x, that is going to be represented by a straight line. You can understand that, right? You have already seen that curve. So that will go like that. But yeah, other curves, if you look upon, so you will have those curves in the same fashion. That means if you keep on increasing the values 3, 5 and 7, the curve will become more closer to the y-axis and it will become more flat. Okay. Now one thing which you have to see is that for the even curve, the value is always, the y value is always going to be positive, because if you take even power of any negative number, you are going to get always a positive number. For example, if I have y is equals to x to the power 4, and if I put x is equals to 1, I'll get y is equals to 1, right? And if I put x is equals to minus 1, then also I'll get y is equals to 1. So in both the cases, I'm getting a positive number. Or let's say if I put x is equals to 2, so I'll get y is equals to 2. So y is going to be 16, and if I put x is equals to minus 2, then also y will be 16. So that means what? That whatever value of x I put, whether it is positive or negative, I'll get a positive term in y-axis. So that's why the curve will only remain on the positive y side. Whereas over here for the odd curves or for the odd powers, if I put a negative number, let's say if I put x is equals to 1, I'll get y is equals to 1 for the function. Let's say if I have function y is equals to x cube. So if I put x is equals to 1, I'll get y is equals to 1. If I put x is equals to minus 1, in that case y will also be minus 1. So that means for negative value of x, you will get negative value of y. So that's why the curve is like this. Now the pattern is same. That means it will become more flat at the bottom, and the curve will shift more towards the y-axis if you increase the powers. Okay, so that's what is about your power functions. So here I have just collectively made all the curve for your y is equals to k x to the power n, where k is some constant which is multiplied with it. So if you have a positive constant, that means if k is a positive number, in that case the curve will be as I have shown you. But if k is negative, that means the number which is multiplied over here, if it is negative, the curve will be opposite of what we have seen over here. Okay, so it will become negative side of that. So that is about your power function taken with a constant as a multiple of that. Alright, now let's talk about a particular type of curve where I have included all the functions like y is equals to x, y is equals to x square, x cube, x to the power 4 and x to the power 5. You can see that this red line is representing y is equals to x actually. Now this blue one which you can see is your y is equals to x square, right? Now y is equals to x cube is represented by this green line because it's an odd power, so it will go in the negative direction also. So y is equals to x to the power 3 it is. This green colored lines, okay, going through like this. The next one is y is equals to x to the power 4 given by this purple line. So y is equals to x to the power 4 given by this purple line on the positive side. And the last is in the orange color, which is y is equals to x to the power 5, which will go like this, okay. So the same trend, all the graph, all the plots represented in the same one, just to show you, just to let you know that how you can compare the graphs, okay, how the graph changes. So let's talk about the logarithmic function over here. Logarithmic function is given by y is equals to log base 10x. There can be any of the base. This is called as base, okay. So log base 10x. So this is a log which has a base of 10. There can be any base, like it can be natural log with base e, or it can be base 2 or 3, anything can be there in the base. But right now this particular curve is telling you about log which is of base 10, okay. So here you can see in this particular graph that it's going from minus infinite in the y-axis, and it is going towards the infinity in the x-axis as well. But the intercept is being made on the at a point 1. So this is because you know that if you have log base 10x is equals to y, so you can say that x is equals to 10 to the power y, right? Now this is the value which again you have now converted this function in the form of your exponential function, but this is reverse of that. Remember, the exponential function was y is equals to 10 to the power x. Now you have just interchanged x and y over it, so it is going to be just reverse of the exponential function. That's it, okay. Now if you put, this is what function we have. So if you have any value of x, let's say if you are putting y is equals to 0, okay, in that case x will be 1. So at the place when the y will be 0, your x is going to be 1. So the coordinate of this particular point will be equal to 1, 0. So, and if you keep on increasing the value of x, you will get increased value of y. So that's what the logarithmic curve is about, okay. The difference between logarithmic and exponential curve is that for exponential curve, for a change of 2 digits, let's say between 2 and 3, there will be a huge gap, or there will be a huge change in the values, okay. If you look upon the exponential curve, this is what we have. So if I just go from value of 1 to 2, I can see that there is a huge change in the value of y. Okay, the value of y changes up to a very high value. So it has a this much difference over here. Whereas if I go in the logarithmic function and if I just take the difference between value 1 and 2, I will find out that the difference in the y value is not much. So in order to express a data in order to express a data over a long period, we generally favor to take it in the logarithmic function rather than in the exponential function. So exponential growth are also expressed in the form of logarithmic function when we have huge data and when we have to express it and we have to see the changes. Okay, this example you can see right now as a real-time one. If you remember that there is a website to find out or to tell you about the COVID cases in India, right? So if you click on that website, you will see at the bottom you have different options to see the number of cases which are increasing in the uniform manner, in the exponential form, and also in the logarithmic form. So if you see in the exponential form, the curve will increase like this. But when you change it in the logarithmic form, you will see that the curve will increase something like this. Okay, it becomes somehow straight. That is because in the exponential curve, for a little bit change in the x or little bit change in the x value, we have a huge difference in the y data. Okay, or the huge difference in the y values. Whereas for the logarithmic curves, that is not the case. Okay, I hope you guys understood it. You can check that out for that particular on that particular website right now. But yeah, this is the difference between your logarithmic and exponential curve is. I'm not going into the technicality just for the sake of making this video very clean and very basic. Okay, I just don't want to go in the details because I can also explain these things on the basis of functions and the domain and range, but we are not going in the terms of that. Okay, I'm just trying to keep it in such a way that even a non-mathematics student also understands. Okay, now the base value, if you change for the logarithmic curve, if you change the base value, here we have base 2, here we have base 3, and here we have base 4. So as you can see, if the base is being changed, the graph is turning more towards the x-axis. Okay, the graph will become more closer to the x-axis. So now you can see that if you have natural log, that means y is equals to log base ex, and you know that e is equals to 2.708 something. So in that particular case, the curve of that of this particular one will go in between of 2 and 3. Okay, so the curve will go somehow over here like this. Okay, this will go like this. This is going to be y is equals to ln x. It is denoted by ln x, which means log base ex. Okay, so this is called as natural log. So it can be represented in that way as well. So these are your logarithmic curves. Okay, now you can see the difference between the exponential curve and the logarithmic curve. You can see here both these curves are represented and both are actually just like a mirror image of each other. If you plot it against a straight line curve, which is y is equals to x. So here three curves which we have, or three functions which we have already studied, they have been shown in the same graph. This is a straight line, this is an exponential curve, okay, called as, basically this is the exponential rise or exponential growth. Okay, and this particular one is logarithmic growth. Okay, logarithmic growth. So that's how the curve changes. You can see that it's a kind of mirror. This y is equals to x is acting as a mirror for these two curves. The coordinates, or the, you can say the intercepts on the y-axis is 0, 1 for the exponential curve, whereas for the logarithmic curve it is 1, 0. You know how to write on these, right? First of all, we write down the value of x coordinate and then we write down the value of y coordinate. So it goes like that. And for this, it will be 0, 0. So this is how the exponential curve and the logarithmic curve and the straight line can be represented on the same graph. I hope this is much clear to you. Next, let's say we have three types of curves over here again. This is your exponential curve, this is polynomial curve, and this is a straight line curve. All of them are represented in the same phase. You can see that this is a straight line curve, right? Y is equals to 50x. You have to tell me in the comment sections below that if it is a straight line, then what is the slope of this line and what is the intercept of this line. Okay, so these two things you have to tell me in the comment sections below. So this is that y is equals to 50x. The other one is y is equals to x cube or fx is equals to x cube. This is your polynomial curve denoted by this blue line, and y is equals to 2 to the power x or fx is equals to 2 to the power x, called as your exponential curve, and that's represented by the green line. So three curves of different types represented in the same pattern, okay, or in the same graph. Next is your trigonometric functions. So there are 6 trigonometric functions. Those are sine x, cos x, tan x, cosec x, sec x, and cot x. Okay. The full name is sine x. It is called as cosine x. It is called as tangent. It is called as cosecant. It is called as secant. It is called as cotangent. Okay. So these are the names of these functions basically. So the sine x curve or the sine function goes like this. It starts from 0, it goes in the negative direction as well as in the positive direction, the waveform. Remember that it will strike the x-axis or it will bisect the x-axis at 0, at pi, at minus pi, at 2 pi. So sine intersects the x-axis at n pi values, okay, at n pi values. So it will be 0, pi, 2 pi, 3 pi, 4 pi, it will intersect over there. And the values will always be in between 1 and minus 1. Okay, so on the y values will be either less than 1 and greater than minus 1. So it will be between those two. Same goes for your same goes for your cos x. But here the curve starts from 1. That is the only difference. It starts from 1, either starting from 0. So it is going to strike the x-axis at n pi by 2, where n should be odd number. Okay, it should be odd integer basically. So if you put any odd integer like 1, 3, 5 and so on, it will tell you that where this cos x is going to strike the axis or it is going to intersect the x-axis. Okay, and for the y-axis it will again have the values between 1 and minus 1. Rest of the functions like your tan x, cosec x, sec x and cot x are not that much usually used in your chemistry. The sine x and cosine x or cos x are generally used in your quantum chemistry. That's why it is important to understand. Okay, rest of them are not generally used. So you can just look upon the graphs, but you don't have to understand that in that much detail. You just need to know the sine function and the cosine function and how you can form them. So in quantum mechanics, if you remember, the formula for the particle in one-dimensional box has a wave function of under root 2 by L, and it goes like sine n by x by L, right? So here it is a sine function. So that's how there you have to utilize that. So once I'll teach these quantum chemistry and the other terms which I have discussed like kinetics and all, so when I will be talking about the functions, if you understand from this particular video about all these functions, it will be much easier for you to understand when I will teach them. The last is when you combine functions with a modulus function. It's a very important type of combination which is usually seen in your quantum mechanics generally, because whenever you have a wave function and if it is asked to find out the probability density, okay, of that particular wave function, you just take modulus square of that, right? So in that particular case, you need to find out that what is going to be the mod function of any type of function, right? So if you have sine x, so sine x was having curve like this, right? This was having curves like this. So if you take the mod of that, the curve will become only positive. Okay, you will just have the positive values. The negative side also become towards the positive side. Same goes for log x. If you remember, for the log x, the curve goes like this, right? It was going through the x point over here like this. But if you convert this into your mod log x, okay, so in that case your curve, this negative side will come to the positive side like this, and the positive one will remain positive. So that is what is going to be changed whenever you have any modulus function. So I hope whatever I have taught in this particular video, whatever I told you about different functions is much clear to you. You understood all the types of functions. This is just kind of, those who already know it, it would be just kind of a revision for you. Those who don't know it, I guess now you might be much familiar with functions and the graphs, how they look like. And when in the physical chemistry or in quantum mechanics or anywhere, when you will come across a particular function, you will be able to recognize that. Plus, you will be able to understand that why that particular function has a particular graph. Okay. Now this video is going to be very helpful for your GATE preparation for your CSNet preparation, for your IT exam preparation, for TIFR exam preparation. So any exam which you are going to give based upon the numerical, physical and graphical types of question, this video is going to be very helpful. So that's it from my side, guys. Thank you so much for watching, and I hope that whatever I taught is much clear to you. If you have any doubt, you can ask me in the comment sections below. I'll recommend you to explore more about these functions, to solve more questions related to that, and just see that how function changes on applying different conditions on it. Okay, so that's it from my side, guys. Thank you so much for watching, and if you like this particular video, give it a like. If you have not subscribed to the channel, subscribe to the channel, and if you want to share this knowledge with your friends, share it on your Facebook and WhatsApp groups. So that's all, guys. Thank you so much for watching, and do let me know in the comment sections if you want to ask anything. Alright, so take care.